Simplifying rational expressions is our third lesson, and the steps for simplifying rational expressions are factor the numerator, the top, and the denominator at the bottom if possible. So factor means difference of squares or GCFs. That's what you're basically going to look for, GCFs or difference of squares. Number 2, state the non-permissible values, the restrictions. So after every single time when we're going to do multiplying and dividing as well, you're going to do your GCF or your difference of squares on all of the tops and the bottoms, the numerators and the denominators. And then you're going to state the non-permissible values with the denominator can't equal. And then you will cancel. So number 3 is cancel the factors that are common to the numerator top and the denominator bottom. Has to be exact replicas of each other. Like if a sign is different, you can't cancel them. Okay? Now, we always cancel after we state restrictions. If we cancel before we state restrictions, you're going to be missing some restrictions. Okay, you're going to be missing some MPVs. And that answer will be there on the diploma if you state it after you simplify or before you simplify. When 1 is the only thing you can take out, it's simplified. You can't make it any better. Okay. Example 1, express the following rational expressions in simplest form. State the non-permissible values as restrictions. So for A, we have 12x squared in the numerator in the top and 2x in the denominator in the bottom. Can I take anything out of 12x squared or 2x? In the top, nothing. In the bottom, nothing. They're just all multiplied together, right? So they're simplified as they can be on the top by itself and on the bottom by itself. Now, what I always say to do is if you have numbers that are multiplied together, put them in their own brackets. If they're connected by a plus or minus sign, then they get connected in their brackets, right? So in this case, I'm going to have a 12 in a bracket, and I'm going to have an x squared in a bracket because they're multiplied together. And anything that's multiplied together, I put in its own brackets. And then I have a 2 and an x. Okay? Now some people like instantly super excited that they can cancel something off. Stop yourself before you cancel, because what do you have to do first? State NPVs, restrictions. Yes, you have to do that first, or else you won't have a restriction, because we'll cancel the x off and you'll say there's no NPVs, and you'd be wrong. Okay, so before we go to cancel, we have to stop ourselves and say state restrictions. So our NPV or NPVs, 2 can't equal 0. Is that an NPV? No. Only variables make you NPVs. So this we don't have to worry about. And then x can't equal 0 would be our only non-permissible value. Okay? Once we've stated non-permissible values, then we can cancel off like terms. Is there anything that I can take out of the top and the bottom that's the same? 12 and 2. Is there anything I can take out of both of those? Divide by? You divide them both by 2. So if I divide this one by 2, the denominator, I'm left with a 1. And I divide 12 by 2, I'm left with a 6. Because they're in their own brackets, right? Because they were being multiplied. Then I have an x squared and an x. I can take an x out of both of those, right? So if I divide x by x, it goes away. If I divide x squared by x, the squared goes away and I'm left with 1x. So in the numerator, I'm left with 6 times x, so 6x. In the denominator, I'm left with 1. Because anytime you cancel something off, it's just a 1. So I have 1 times 1 times 1, which is 1. Do I have to write 6x over 1? No. What if it was 1 over 6x? Would I have to keep the 1 then? Yes. So if the 1 is in the numerator, you have to keep it. But if the 1 is in the denominator, you don't have to write it. So our answer is going to be 6x, and then a little comma, x can't equal 0. You'll state your non-permissible value behind it. And that's the simplified version of A. Let's look at B. So GCF for difference of squares, they're already factored. So that's good. Now some people start going all crazy with their canceling. So they're like, I got an A, an A, an A, an A, an A. First off, we have stated non-permissible values. You shouldn't be canceling, right? But pay close attention. Put your pencil down and pay close attention. The only way A minus 7 is going anywhere is if there is a bracketed A minus 7 in the numerator. Is there? No. So this A minus 7 is going nowhere. It is staying for life. It is going nowhere. You can't cross the A off on the top. You can't cross the 7 off of the 7 in the numerator. A minus 7 has to be completely replicated in the numerator in order for it to go away. You can't cross off parts of this. It's connected with a minus sign. The only way A minus 7 is going away is if there's an A minus 7 in the top. There is not. That A minus 7 is staying for life. Okay? In the top, I have an A minus 6 in brackets. Do I have an A minus 6 in the bottom in the denominator? No. It is staying for life. It is not going anywhere. You can't simplify it. You can't cross the A off with another A on the bottom. It is A minus 6, and unless there is an A minus 6 in the bottom, it is staying. Okay? That's the biggest error. People oversimplify. Anyways, we can't cross off the A plus 1s yet. Why? Yeah. We have to state NPVs. So if we cross off this A plus 1, we're going to be missing an NPV. Okay? So we have to state NPVs first. So our NPVs are A minus 7 can't equal 0, and A plus 1 can't equal 0, and then we have to solve them. Add the 7. A can't equal 7. Subtract the 1. And A can't equal negative 1. So our NPVs are A can't equal negative 1 or 7. And sometimes the question is just that. What's the non-permissible value? You don't even actually have to simplify it, right? So whenever we have a variable in the denominator, we are always stating non-permissible values. Because the moment you have a variable in the denominator, that variable could be a number that could cause the denominator to be 0, and that's an issue. Okay, we've stated our NPVs, now we can cancel. We have an A plus 1 in the numerator and an A plus 1 in the denominator. So we basically have a little replica of each of them in the top and the bottom. So they can go away. So then it equals A minus 6 over A minus 7. Now to cause yourself to not oversimplify, whenever there's a minus or plus sign, I just leave them in brackets like that. Do we absolutely need the brackets? No. But the moment you put brackets there, I get less people trying to cross off these A's. You can't cross off these A's. This is A minus 6. It's like its own human. This is one human. It's A minus 6. The only way it's going away is if there's another human that's A minus 6 on the bottom. If not, you're crossing off this person's head and this person's head. You are decapitating people. You are horrible human beings. Okay? Don't decapitate people. This is one person. This is another person. They look very similar, but they are not the same people. You cannot cross them off. This is done. Do you know how many people will cross off A's on the quiz tomorrow? A lot of people. Don't. You're decapitating people. Okay, that's very horrible. So, A can't equal negative 1 and 7 follows behind, and that is as good as it gets. Please don't try and make it better. That's where the errors happen. It's not that people don't know how to simplify, they oversimplify. So, give the quiz tomorrow. Do you know how many of you cross off the 8 Y's? Decapitated a person for another person. That is not good. That is really bad. We do not do that, right? So, whenever there's a plus sign or a minus sign, I put that in brackets so that it stops me from trying to overcross off things that can't be canceled, right? This AY is attached to a plus 2. Is this 8Y attached to a plus 2? No, it's going nowhere. So we ask ourselves, is there something I can take out of that 8Y plus 2? Yeah, 2. So in the top, I can take out a 2, a GCF of 2. 8Y divided by 2, I'm left with 4Y, plus 2 divided by 2, I'm left with a 1. Please, you guys, when you take a 2 out of 2, you're still left with a 1. Don't cancel that off. That's the other error that everyone does. They make it be just 4Y. Now that 4Y plus 1 is in brackets. Is there a 4Y plus 1 in the denominator? Will there ever be a 4Y plus 1 in the denominator? No. So your answer better have a 4Y plus 1 at the top of it because it can't go away. It doesn't have a matching one on the bottom. So when you write your answer, there better be a 4Y plus 1 on the top. Okay? This 8Y, is it attached by a plus or minus sign? So I can put 8 in its own bracket and y in its own bracket because they're not attached, right? They're just together with a multiplication symbol. So if they're attached by a multiplication, you can just write them separate. So 8 and y. And this 2 can be in its own brackets too because it's being multiplied by the 4y. Do you see? If it's attached by plus or minus signs, it has to be in its own brackets. But if it's just multiplication, you can put them in their own separate brackets. If you bracket all the separate multiplications and you bracket the additions and subtractions, your mark will improve drastically on the test because you will cancel off way less things that you're not supposed to cancel. I've found that the more brackets, the bracket placement makes people's marks better. Okay? So put brackets when they're like this. So I'm going to cross off the 2 and the 8 because I can take a 2 out of both of them. And you say, yes, you can, but what do you need to do first, Lepp? State NPVs. The moment you go to cancel something off, say, did I state non-permissible values? No, I have to. Okay? Always. Would it have changed my non-permissible value in this case? No. But you always state non-permissible values before you cancel. So my NPVs would be 8 can equal 0. No. It doesn't have a variable, so I don't have to state non-permissible value for this. It's 8. It can never be 0. It's 8. So I take the y, and I say y can't equal 0, and I'm done with that one. I'm done. I have my NPV. Now I stated my NPVs. Can I cancel now? Yes. Is there a y in the numerator by itself? Or a y, if I had a y squared up here by itself or a y cubed up here, that I could still cancel, right? Do I have one of those up here by itself? No. Can I take this y and this one out? No. This is a human being. It's 4y plus 1. This is another human being. It is y. You cannot cross this y off with this one, right? Now, 2 and 8. Can I take something out of those? The 2 that I said, right? 2 divided by 2 is 1. 8 divided by 2 is 4. So my answer is 1 times 4y plus 1. So just 4y plus 1. It's still there. It's going to stay there. There is no matching one on the bottom. On the bottom, I have a 4 and a y. Do I really need all those brackets in the answer? No. I could have 4y plus 1 on the top and 4y in the bottom, no brackets. Absolutely. It's the same answer. However, do you know how many people I get going 4 and 4? A lot. That's wrong. You can't do that. What about y and y? No, you can't do that. Can you do 4y and 4y and just have a plus 1 on the top? And they have it equals 1, and they're just so happy because it's just simplified to something so nice. And you're wrong, but you were right. But then you kept going, so stop yourself. Okay? 4y plus 1 is going nowhere. So 4y plus 1 is going nowhere. Neither are these because they have nothing to cancel off with. We're done. Y can't equal 0. So could I write this 4y plus 1 over 4y? Y can't equal 0? Absolutely. With the brackets, still correct. But the brackets won't be on your diploma. Like, it's not going to be bracket, 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 bracket. But the brackets here will get you to stop canceling. Just know that this is the same as this. Okay?
How come in the numerator, the 8y doesn't get broken up into 8 and y? You do it.
Because the 8y itself is attached to the plus 2. Okay. So the moment...
The 8 and the y aren't attached. How come they're attached on the bottom?
Because they have the plus 2 behind them. So if this had like a plus 1 back here, then the 8y would be stuck together. Because the moment that this has a plus in here, that means that this front, this is like the head, and this is the feet, and they're attached. You're right. It is confusing. But the moment there's that plus sign, that's why I say put brackets around it so you don't cause yourself to do that. Yeah. I can see how that's confusing. Okay. I want you guys to try D, E, and F. See how you do. D, E, and F. With D, there's 2 ways we can look at this. I like looking at it having a positive X, but it doesn't really matter if you leave it like this. What does matter is that the denominator, when you do difference of squares, is going to be a 7 in the front of the brackets and an X in the back of the brackets, because it's 49 and negative x squared, right? So the top is going to stay negative x plus 7. The bottom is going to be a difference of squares. It's going to have a 7. Square root of 49 is 7. And square root of x squared is x plus or minus. Now, before we cancel or do anything, we have to state non-permissible values. So we have 7 plus x can't equal 0, and 7 minus x can't equal 0. Subtract the 7. X can't equal negative 7. Add the x. X can't equal 7. So x can't equal plus or minus 7. Now, the top is negative x plus 7. It's attached, right? By plus sign, so it's in brackets. Is negative x plus 7 in the numerator the same as anything in the denominator? Yeah. The 7 minus x. Because remember, we look at what signs are in front of it, as long as the signs are the same. So I have minus x plus 7 plus 7. They're actually the same. So this one cancels off this. When I cancel off the entire numerator, what's left behind? 1. So this is actually equal to 1 over 7 plus x. If you put just 7 plus x, that's going to be the common error. And it's wrong. You still have the 1 left. So when the entire numerator crosses off, you're left with a 1 on top. You have to have the 1 there. So our answer is 1 over 7 plus x, or x plus 7. It's the same thing. And then x can't equal plus or minus 7. E. I asked myself, can I take anything out of the numerator? What can I take out of the numerator, Ryan? A 4p. So if I take out a 4p, I'm left with 12p squared divided by 4p. I'm left with 3p minus 2, because ap divided by 4p is 2. Now this 4 and p, are they attached to each other? No. So we can put them in their own brackets. And in the denominator, 6p cubed minus 4p squared. Great. So what can I take out of 6p cubed minus 4p squared? Yeah. 2p squared. Yeah. So you can take out a 2p squared. Is this 2p attached, p squared attached to each other? Is there plus minus signs in between them? No. They can go in their own brackets. When you take 2p squared out of 6p cubed, 6 divided by 2 is 3. P squared out of a p cubed, you're left with a p, minus 4 divided by 2 is 2. P squareds cancel. Now people get super excited because they're like, yeah, stuff's canceling. I'm actually not doing this question wrong. And they start canceling. But what do you have to do before you start canceling? NPVs, 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 NPVs. So, can 2 ever be 0? No. P squared can't equal 0. You just take the square root. You take square root plus or minus the square root. It just happens that when you take the square root of 0, it's just a 0. So if you have a p or p squared or p cubed by itself, the NPV for all of those is it just can't equal 0. Okay? And then 3p minus 2 can't equal 0. Add the 2. 3p can't equal 2. Divide by 3. P can't equal 2/3. Now that I have my non-permissible values stated, so my non-permissible values are p can't equal 0 or 2/3, then I can cancel. 3p minus 2 matches exactly on the bottom and the top, so cancels. What can I take out of the 4 and the 2? 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. And then the p and the p squared, what can I take out? A p. So p out of p cancels. A p out of the p squared cancels off the squared. So on the top, I'm left with 2 times 1 times 1 times 1. Anytime these cancel, these are actually little ones. See, they all make little ones. So it's actually 2 times 1 times 1 times 1. So I have a 2 in the numerator. And then the bottom, I have 1 times p times 1. So just a p. I guess I didn't need to make that long. And then And then I have p can't equal 0 or 2/3. F, what can I take out of the numerator in F? Because right now it's not a difference of squares. What can I take out? 3. I take a 3 out, I'm left with t squared minus 25. T squared minus 25 is a difference of squares. And the bottom's just factored. So it's going to equal 3, and then t squared minus 25 breaks into 2 factors. Square root of t squared is t. The square root of 25 is 5. And then opposite signs. So plus or minus plus, doesn't matter. And then we have t plus 3 on the bottom. T minus 5. So before we go canceling, we state our non-permissible values. T plus 3 can't equal 0. T minus 5 can't equal 0. Subtract 3. T can't equal negative 3. Add 5. T can't equal 5. So t can't equal negative 3 or 5. Now, the t minus 5s are obvious to cancel off, correct? And then I can just cross this 3 off with that 3, because I have a 3 in the top and a 3 in the bottom, so I can cancel them, right? No, no, why can't I? Because they're different people, right? This one here is t plus 3. The only way t plus 3 is going anywhere is if there's a t plus 3 on the top. Is there? No. T plus 5 is only going anywhere if t plus 5 is on the bottom. No, and then this 3 is just there. Can't get any prettier than that. So it's just going to be 3 t plus 5 over t plus 3. And then t can't equal negative 3 or 5. Okay, here's your turn. So basically, the first one, you have 18x4. You could, if you wanted to, because this is an x4 by itself. X4 means I have 4 x's. So I could write it like this if I wanted to. 18 times x times x times x times x. 4 x's. And in the bottom, I could technically go 36 times x, 2, 3, 4, 5, 6, 7. It's not time consuming at all. But if you'd really like to do it that way, you can go ahead. Okay? That's why whenever you have like an x7 by itself on the bottom, or x to the squared on the bottom, or x cubed on the bottom, your MPV is just x can't equal 0, because you technically have 7 x can't equal 0 MPVs, but you would only write it once. Okay? So our MPV is x can't equal 0. Then this x can cancel this one. This one can cancel this one. This one can cancel this one. This one can cancel that one. So I technically have 3 left on the bottom. Or you could say, hey, I have 4 up here. I have 3 left on the bottom. Either way you want to do it. Bless you. Then the 18 and the 36, I can take an 18 out. 18 divided by 18 is 1. 36 divided by 18 is 2. So I'm left with 1 times 1 times 1 times 1, 1, 1, 1. So 1 in the numerator. And then 2 times 1 times x times x times x times 1 times 1 times 1 times 1. So that's 2x cubed. And x can't equal 0. For b, I can take a 3y out of the numerator. And then 3y divided by 3y is 1. It doesn't just go away. Minus 9 divided by 3 is 3. Y squared divided by y is y. Over 6y cubed. Which I can put the 6 and the y cubed in its own brackets, and the 3 and the y in its own brackets, because they're not attached to the plus or minus sign. The 6 doesn't get me an MPV. The y cubed gets me an MPV of y can't equal what? 0. Now this 1 minus 3y is going nowhere. There is no 1 minus 3y in the denominator, so that's staying. This y can take off one of these, so I'm left with a y squared in the bottom. 3 divided by 3 is 1. 6 divided by 3 is 2. So in the numerator, I'm left with 1 times 1 times 1 times 1 minus 3y, so the 1 minus 3y stays. And in the denominator, I'm left with 2y squared. Y can't equal 0. And then C, I can take out a 3a squared from the numerator, from the top. When I take a 3a squared out of a 3a cubed, I'm left with an a. Minus 3a squared divided by 3a squared is 1. Now, if I just take a 12 out of the bottom, I'm left with negative a plus 1. And I want positive a minus 1, so I can cancel them. So I actually take a negative 12 out of the denominator. I take a negative 12 out of negative 12a, I'm left with a. 12 divided by negative 12 is minus 1. And then the 3 and the a squared are in their own brackets. So basically I have a minus 1 can't equal 0 for my NPVs. So a can't equal 1. Once I've stated my non-permissible value, then I can cancel. A minus 1's cancel. I can take a 3 out of 3 and I'm left with a 1. I can take a 3 out of negative 12 and I'm left with a negative 4. And so my answer is 1 times a squared times 1. So a squared over negative 4. Oh, and sorry, a can't equal 1. So if you missed yesterday's, you have double the homework because you need to get caught up on equivalence. And you're going to have to do simplifying. So from yesterday's homework, which I'm going to check tomorrow, I'm going to check both of these homeworks tomorrow out of your workbook. If you don't have a workbook, you need to take a picture of the workbook. And if you want, you can pay for it School Cash Online. It's on there. So page 429 was numbers 1 to 10. That was yesterday. And today is page 434. Numbers 1 to 5, 7 and 8. So both of these are being checked tomorrow.